Hey guys, how's everything going? This is Jaser. This is another episode of my YouTube series about React source code. It's episode 22 about suspense. I think I've covered suspense pretty long time ago, but in this time I'm going to dive into the details about how suspense works. So in the previous videos, we've already seen how suspense is very similar to error boundary. Yeah, it's actually internally they're called suspense boundaries and error boundaries. And I've tried a lot to understand what is going on, and to be honest, it's pretty complex. And I'm not going to cover all of them in one episode because I haven't finished that yet. I've decided to split into four parts. So the first one is reconciling how suspense reconciles. This is the basic part, and the next part it's already there. You can visit my blog. It's about off-screen component. It's pretty interesting. And the two episodes left, it's about context, suspense context. I haven't figured out. It's still in progress. Another one is Painting with Try. It sounds pretty straightforward, but still there are a lot of code going on. So basically, the ideas look simple, but the implementation is pretty complex. I had just in this episode, let's talk about the first one, reconciling. So how Suspense component render itself and how it gets updated. So let's first take a look at basic demo. This is a pretty basic suspense demo. When we click the start button, you can see that there's a loading state, and in the background we just marked a promise, and then when the promise is resolved, it render my name and JSON there. Let's take a look at the code. This is a pretty standard, maybe not standard, but a pretty straightforward implementation of a data fetching resource. So the idea is that, okay, this is the code of rendering it. You can see when we click the button, we set the resource and we'll get the resource. And when we get the resource, we're going to start rendering it, right? In rendering it, we would render the name. But when we get to the name, get to the data, it might be not ready. So this resource it could have a few states. One is pending, one is fetching, and one is ready, right? So we only return the data when it's ready. If not ready, it means it's fetching or pending. We just throw the promise. Of course, internally we need to keep track of the promise. So this is just for demo purpose. I'm not sure whether there's a standard way of doing it. I think React team maybe it is working on something. I saw some code called cache, but I'm not sure. But anyway, the idea is that throw the promise, and once the promise is thrown, when we render child, when the promise is thrown, the outer suspense boundary, which is called suspense component here, will be able to catch that and render a fallback. So that's why we see loading, and after a shorter period of time, we render the name. So this is the basic suspense demo. You can click the link here. So we jump straight into how suspense render itself. We've already been covering a few components, which it should be like a mount component, an update component, the two phases, right? So we can see here in begin work, we can see here is that it's only one method of doing both of them, which is update suspense component, which is pretty, I would say, pretty common in the React source code. Is that if the component is some abstract component, there's only one. They just put the code in the same place. Anyway, it doesn't matter that. So when we update the suspense component, this is a huge chunk of code. Let's just break them down. The first thing is that we could see there's a flag called show fallback. Obviously, this is a suspense component to decide whether we should render the fallback or the children it's set, like the child component here. The show fallback, you can see that it says show fallback desuspend. There's an if clause here. It says if it desuspend, which is checking the flag of Discapture, and also some other check, it will set the showback for true. So we are pretty sure that the conditional rendering is based on the Discapture stuff, and after it's set, the flags are removed of this Discapture. Why about this? You think of that like the suspense is an if clause, right? And if we don't remove it, next time we will render, you will still get the Discapture. So we need to remove it to make sure that next time it is rendered, it will try to render the normal children. Here we just call the primary children, which will be covered soon. So remember the Discapture flag about this fiber. For the initial mount, it's just inside of this function. If current is null, it means that there's nothing previously existing. It's the initial mount. So we can see that it says if we need to show the fallback, we mount the suspense fallback children. This is and actually. So fallback and children. And then we get the primary child from the work in progress child. Wait a minute. Oh yeah. Work in progress is the suspense primary child fragment. Oh, I think it's already set in the mount here. So when it's get child, it's the primary child fragment, and then primary child fragment memo state. So this is something about off-screen component. We can just skip it for now. And it's set suspend marker or something. I don't know what it is. But anyway, you can see that if we show fallback, it will render the fallback fragment. Where is fallback from? Oh yeah, this one. This return the fallback fragment. If we do not show the fallback, we show the primary. We just mount suspense primary children. So this is mount the children and fallback. This returned the children. So yeah, we'll cover it in the details, but let's go to the update. So this is an update. There is something already there. Obviously, there are a few combinations, right? Say if it's basically like previously we render fallback, now we render fallback again. If it is fallback, now we render content, or if previously it's rendering content and now we rendered fallback, and otherwise it just to render both content. If like say if we previously rendered content and now we render content, it's basically just like a normal reconciliation, right? We just reconcile the children. And for if we previously render content and now we render fallback, we just replace them, right? Not replace, I would say. How should I put it? There's no reconciling anymore. We just show the fallback. Then we go to fallback. If we fallback and then go to content, now content, we just go to the content. If the fallback and the fallback, we just reconcile the fallback. So let's take a look at it. So if previously is fallback and now is fallback, you can see that next fallback children and next primary children, we would update suspense fallback children, we'll update it, and of course we will go to the fallback child fragment, because this one will give us the next fallback fiber. And again, there are some off-screen component we'll cover in the next episode. And here it sets the child limb, blah blah blah, and it return the fallback fragment. Here, because previously it's render fallback and now we render fallback, we can see that here. Oh yeah, here is update suspense fallback children. It's just does the reconciling. And here is the fallback now content. You can see that we render the primary child fragment. Remember, the return value of the reconciling is decide the next fiber the React is going to work on. So if you say, hey, if previously is fallback, now with content, there's nothing to reconcile, right? It's totally different. So we just update the primary children and carry on. So the other rest two cases are just similar. We'll just skip. So let's go to details about these functions called mount something. Updates. No, wait a minute. Where is it? Oh yeah, mount suspense fallback children, mount suspense primary children, and update a version of them. Yeah, let's go take a look. So this one is mount suspense fallback children. It will mount both of them. Here we can see that primary child fragment, fallback child fragment, and primary child fragment is mount work in progress off-screen fiber. So here we see off-screen fiber again. You can think of it as just like sort of a wrapper. And also this one is create fiber from fragment. This is just a fragment. It will fragment that contain the fallback children, and this one off-screen will contain the children. And here's is interesting. You can see that primary children, we will set the return of work in progress, obviously, because these two should be the children of the suspense. And here it says primary child fragment sibling is the fallback child fragment. So the fallback is the sibling of the primary child, and work in progress child is set to the child. So as we said, it's set here, and then it returns the fallback child fragment. Yeah. Pretty. So I summarize the three steps. First one is primary child is wrapped in off-screen fiber, fallback is wrapped in the fragment, and the fragment child and fallback are both placed as children. So this is interesting why we wrap them. I draw a diagram here. You can see that suspense actually internally hold two children. One is the off-screen, and the other one is the fragment. And for off-screen, it holds the child. And for fragment, it holds the fallback. So this one is internal structure. It's just not visible from outside. From outside, the suspense, we just create a suspense like this, right? Suspense fallback is this one, and this one is children. So internally, this is interesting. We have some internal structures, and the off-screen is to control that is hidden or visible. So what is special about mount work in progress off-screen fiber? Where is it? Mount work in progress. Yeah, here. This is one. How we create the off-screen fiber. It just simply creates fibers from off-screen, and then we create a fiber. Its element is off-screen and sets the length and sets the children and sets the state. So yeah, nothing so fancy. It's just the basic type, element type. Nothing fancy. Oh yeah, something is fancy is that it has a mode property to indicate if it is hidden or visible. So as said here, it's hidden there for now. Mount suspense primary children. I think it's pretty, because we don't need the fallback anymore. You can see the diagram is look like this: suspend, child, and then we also have an off-screen fiber, but it's visible now. It has a child. Yeah. And work in progress also has mode, but it's a different. Yeah, it's for suspense. It's a different mode. It's not off-screen mode. It's something called concurrent mode, no mode, profile mode, debug mode, blah, blah, blah. So this is it. This is how suspense renders. Again, let's recap. We will just recap at the end, I guess. Okay, let's continue. So how promise is called. When the promise is thrown in the child, how the suspense knows how to get it updated with a flag. As we mentioned, it's called Discapture. Obviously, it's slicing into the throw handle area here. We've already seen this in the previous episode about error boundary, in a throw exception, and it completes unit of work. Yeah, so let's see what's in the throw exception. First is mark this fiber as incomplete, and here it will check if the error is thenable. Basically, it should be promise. Yeah, because when we throw a promise, it is true, so it will create a wakeable, and yeah, this is the internal name of the promise. Then, yeah, and then suspense boundary is get the nearest suspense boundary. This is pretty simple. It's just a go to keep retrieving the return and get the parent and found if it is suspense component. So here, if we found the suspense boundary, we would set up a flag and mark as should capture, and then yeah, attach the listeners. In this method, the did capture, the should capture is set, and the other two is about attaching the listeners. We could guess that this will in these two attached listeners, the callback of the promise will be set, right? When it's resolved, we will do something. When it's thrown, we will do something. So that will be done in here. Why there are two of them? One is pin, one is retry. I don't know. I think the retry is the core, but ping is maybe for some performance improvements. But I don't know yet. I'll figure out in the next step in the upcoming future episode. So also there's a condition said, what if we don't found the suspense, which is interesting. It's not illegal to not set the suspense boundary, only if it's not under the sync lane. There are some details. I'll just skip it. But basically, you should set the okay, no. Basically, you should set the boundary unless it is using transitions. I've put up a demo here. You can see that it's totally working without suspense boundary if we are using if the promise is thrown in a transition length. So this is the method. Mark suspense boundary should capture. You can see that it sets the flag of should capture, which is a slightly different from what we have covered, which is the did capture. So there must be some phases this flag is modified. Where is it? Yeah, nothing fancy. So we go to the complete. When we throw, we handle the error, then we will complete because it's errored, right? We need to complete. There's nothing we can go on, so we need to complete. Yeah, when it is complete, we were looking at the incomplete branches here. Okay, completed work. Yeah, here is if we're complete or something new. Incomplete. Oh yeah, and then this is the incomplete. Yeah. It's pretty complex, I would say. Let's just recall what we have covered in previous post about how traversal is done. React will go to fiber and go to the child and go to sibling, so it's basically a DFS approach. But every time there will be 2 times the React will enter a fiber. One is begin, one is complete. So let's say here, there's no here, no, okay. So begin 1, and then begin 2, and begin 3, because there's no children, will complete 3, and then begin 4, begin 6, complete 6, and begin 7, begin 8, and then complete 8, and then complete 7, because there's nothing more, you will complete just children. So this is like a linked list. So for the completion, you can see here is that, yeah, here it will unwind some work. We can ignore it, I guess. I haven't figured out what it does do. It's do some cleanup. Actually, yeah, here unwind work just to clean up something. I'm not sure what they're clean up. But anyway, here in the complete one, it offers a chance to continue some work if it is returned from unwind work. It will also recursively mark an ancestor node to incomplete, which is just true, right? When the promise is thrown in the children, it's not complete, and the experiment is not complete until we find the first suspense. When we go to here, so when we go up to the suspense, you can see that we would check the existence of the should capture, and it will update the flag to did capture. It will remove this one is bitwise operation. It will remove the should capture and add the did capture. And here is interesting. It will return itself. So as we remember, the work loop about reconciliation is that it will keeps working on the work in progress. So if you will return a work in progress itself, it means that, okay, myself is complete, and then the React reconciler will just start working on this fiber again. Yeah, when it's returned now, it means that wait a minute, complete now, it will go to this parent because it is complete phase, right? It's complete. As we mentioned here, when we complete 4, it will render if return. Yeah, if we return now, we will check if the sibling is there. If the sibling there, we'll go into sibling. If not, we'll go to its return, which is 2. So here, it returns working itself, return itself. It means, okay, this is suspense. When we do the unwind work, go here, we mark it as did capture, and then stay there. And work loop will again go to here and start reconciling. And in this time, because the flag is already there, it will render the fallback branch. Wow, looks simple, but there's a lot of code working going on. Let's just quickly recapture. Okay, So next time when you are asked about how suspense work, you can answer at least with the general idea. So the suspense component uses a flag called Discapture to decide whether we should render the fallback or the content. So if the Discapture is true, it will if it is true, it will mount the children and mount the fallback, but return the fallback. So the component there is actually skipped. Yeah, and when a promise is thrown, React will go up to the first suspense, which is called the suspense boundary, and will set the should capture flag there, and mark it as incomplete, and will start to complete the work of the error fiber, and then go up again, do some cleanup, and when it arrives at the suspense, it will stop there, and the React will goes to that fiber again. So this time it will render a fallback branch. But if the Discapture flag is instantly removed after it is used, so next time when the suspense is rendered again, it will try to render the children again. So this time, if the promise is already resolved, then it will successfully render the content. No error is thrown. But if not, it will throw the promise again, and the fallback is rendered again. So that's it. Hope it helps. Still, there are some parts I'm not very familiar with. But anyway, I hope you can get a brief understanding of how it worked. Especially this chart. I hope you can somehow get familiar with it. So suspense internally has the off-screen component, and also in the React 18 official blog, the React team has already decided to already announced that they will will expose this internal off-screen component for common use. I'm starting wondering if they can expose some low-level ability of this fiber. Yeah, I'm not sure. If exact is exposed, we could actually create something very crazy, right? But maybe that's against the team's will. They want to make the APIs as concise as possible. But anyway, that's the suspense. In the next episode, I will try to cover about the off-screen component, which is also very interesting and also very complex. Stay with me. Yeah, let's learn some React. See you soon. Bye bye.